All right, so I had a student that sent me some very interesting pictures. So you can see here, saw something interesting as I was driving and thought of you. All right, so here he's driving along and seeing a truck. He thought of me, interestingly enough. So he says here, interesting, a liquid nitrogen refrigerator van, right, or truck here. I wonder how they pack all the heat pump equipment into those tiny boxes. Right, he's got this box at the back, right, but he keeps going. I spy something beneath the tank. Right, see these very finned type instruments. Check it out. What looks like a heat exchanger chilling in the breeze. Right, so somehow they got to keep things cool in here. You see in here it said nitrogen, refrigerated liquid. How are they going to keep it refrigerated? Well, they got to have the cold, which is on the inside. So the inside that's in the tank here. If we draw our quicker TS diagram on here. So TS. And we're going to go around the vapor dome here. So go up and then down over isenthalpic process, go across here. So here's our Q in and here's our Q out. This is going from the refrigerant or the nitrogen within the truck going into the refrigerant, and this is coming out of the truck. So this right here is the heat rejection. All right, so this is Q dot out of the process here, through these finned appendages or heat exchanger that's on the bottom of the truck. All right, so you can just check that out if you see one of these again. All right, so again, actual cycle, what do things really look like as we deal with the refrigeration cycle? We probably want to get all the way, for dealing with a compressor, we want to be completely in the superheated area. We're going to have some type of efficiency, so we're going to shift to the right a little bit. We won't be nice and isentropic vertically. We want to be a little bit above our warm region, so we can have a place where we can reject the heat spontaneously, as well as here as we go through the evaporator. A little bit into the liquid area probably here as well before we go through the throttling process, and then again below the cold region down here. All right, so a lot of things we saw with the vapor power cycle just backwards. All right, so the efficiency for the compressor through the compressor is going to be our H2S minus H1 all over H2 minus H1. So basically the smaller value, the difference between H2S and 1 divided by the bigger value of H2 minus H1. Right, as I pointed out, superheated and then subcooled there at state 3. All right, some refrigerant properties. So we had CFCs, or chlorofluorocarbons, or Freon. This was used in the 1940s, early 1990s, discontinued due to concern for chlorines. Right, the chloro part there is effect on the ozone. HFCs, these were developed to replace the CFCs. Refrigerant 134A is the most popular, environmentally acceptable substitute for the popular CFCs. Replaced the chlorine atom with a hydrogen atom. All right, so that's good. Moving on from that, we had HCFCs. All right, contains some hydrogen to replace chlorine atoms. This example here is refrigerant 22. So this was refrigerant 134A, and actually I've seen some soda machines that if they have, if you can see the compressor in the back, you'll see R134A on it. Here we're using R22. So they're currently looking to phase out HCFCs because, again, they're back to the chlorine pieces. Some other fluids that are under investigation for future use. One of them is R744, and this is just pure CO2, especially in industrial settings, as well as R290, which is pure propane. All right. Yeah, so really big in industrial settings are those two. This is from a conversation with a graduate who works at a local refrigeration company. All right, so those are kind of up and coming that you may see at some point. All right, so some background there on some refrigerants. So how do we choose a refrigerant? Well, let me draw a TS diagram here. All right, so we got the vapor dome, and we have a cold region, and we have a warm region. All right, we want to get things into the warm region, and we want to get stuff out of the cold region. And so when we draw our diagram, or we start figuring out what kind of temperatures we need to be at, we need to make sure that we can interact with it in such a manner that we are below the cold region and we are above the hot region or warm region. So because the instantaneous because the spontaneous temperature change is going to be in the direction from the hotter to the colder. So we want to be, again, above the hot region and below the cold region. So choosing a refrigerant is such that we can be below the cold region when we're down here in our vapor dome, going through the vapor dome at a given temperature and pressure, as well as up here above it. All right, so that's the choosing, and a lot of that's through experience, and so that'd be something as you go into a company that they would give you some pointers on, or something that they're used to specifically using. But for designing stuff, then you have to come back and actually look at what temperatures and pressures that refrigerant would pass through the vapor dome at to get the right refrigerant for your process. All right, new property diagram here, mainly because of its convenience. This is a pH diagram. So it doesn't look at acidity or basic when we think about pH, but it looks at pressure and versus enthalpy. And the reason why we like this is because from 1 to 2 we have an isentropic process, or could have it. It might shift a little bit to the right. But then after that it's a constant pressure, right? Heat rejection, an isenthalpic process through a throttling, and then a constant pressure heat addition. All right, so we got a lot of straight lines, hopefully, and only one line that wouldn't be straight, and it just goes along the constant entropy or just slightly off of it. All right, so we use this a little bit, but I just want to give you awareness of that, but we'll still mainly use the TS diagram. All right, so that's what I'm covering here. We'll go do this example in class, so I hope that was helpful. Let me know if you have any questions in the comments below, and I hope to see you at the next video.